Hi, this is Matt in London. The topic of this new video is multi-threading both in C# and C++. So multi-threading, anything asynchronous, that's the topic of this video. I'm going to touch on the .NET events, the background worker class, the task class, and the await keyword. And for the C++ side, I'm going to talk about the thread class, the async keyword, and the futures. How do you make asynchronous calls with .NET events? Is it actually possible? Well, yes, it is. .NET events, by default, you use them when you raise an event. The call is going to be synchronous. Everything is going to happen within the call stack. It is also possible to make asynchronous calls. So how does that work? Well, you create your delegate type, you instantiate your delegate. At the point where you instantiate it, you pass to the constructor a lambda, which is the function you want to call asynchronously. So for instance, a call to a web service that returns the weather, get weather web service. Then you're going to call begin invoke that will allow you to specify the callback. And the callback is the function that will be called when your call completes. So once your get weather returns, something will be executed, and that will be the callback. So that works. One word of warning though, the callback will be executed on the worker thread, not on the caller thread, on the worker thread. So if your caller thread was a UI, and you are planning to update the UI with once the call completes, and once the get weather call returns, you are planning to update the UI with the weather details, well, no, that's not going to work. You're not going to be able to do that. But this is a little bit crap. There are much better ways of doing it now. So then there's the background worker, which you might have used a few years ago in before .NET 4.5. So the background worker is used then in UIs, and it's convenient. Well, it used to be convenient because you can use it to run things in the background, okay? And you're gonna define an event, which is a do work event that will contain the lambda that will run in the background on a different thread, and you're going to register with a you're going to register with a work completed event, which when it completes will be called on the caller thread, so on the UI thread, which is actually very useful because usually when your asynchronous call complete, typically what you want to do is to update the UI. So you want that to be called on the UI thread. So this is how you did it. So you define the asynchronous operation on the work, the callback on work completed, and then you also had support for things like progress updates, errors, exceptions, and cancellation as well. So all those things. So now really you don't use that anymore. Okay? You don't use the background worker anymore because it's actually quite cumbersome. It's not that easy to use. So nowadays what you use is either the TPL, okay, the system.threading.task class, task of T, or even better, the async and await keywords, which are actually very, very convenient to do this kind of thing. Still about starting asynchronous operation, another way to start an asynchronous operation is inside the TPL, the task parallel library, you've got the task class, so task of T. So the way you start an operation with it is just you do task.taskFactory.start new, and this is going to start an asynchronous operation. And yeah, that's it's very useful. Why? Because now this task of T object, first it's task of T because it returns T. So T is a return value, so the assumption is that you start an asynchronous operation. The operation is going to happen somewhere else on another thread. Although this is not up to you, this is up to the compiler. The asynchronous operation is going to happen somewhere else, and when it completes, it will return a return value. Okay, and that's the type T. So then, once you've got this task object, really this task object represents your asynchronous operation. You can do all sorts of things with it, such as, well, checking for completion of the operation. Okay, you can do that. You can also wait and block your thread until completion of the asynchronous operation. And then of course you can get the result, which is sent back by the asynchronous operation. So that's it, that's the task of T, very convenient. And this is actually, this is then used later on in C#5 by the async and await keyword. The await keyword works together with the task of T, and the task of T is actually, in that case, used as a future, which is the same as a future in C++. Okay, in C++ you use futures, which are really objects that simply represent the asynchronous operation. It's exactly the same thing. So the future in C++ is equivalent to the task of T in C#. TPL take 1, 3, 2, 1, lens. Yes. Then the TPL. So now let's talk about the actual interesting stuff. Await. So await, this is really what's interesting, because this is what makes things really easy to use. So the way you use it, you're inside a method, okay, and you're writing an asynchronous call. So you're gonna write await, and then the function you're calling, and that function is asynchronous. So you write await, the function call, and then the statement that's immediately after the await, and that's the key. The statement that comes immediately after the await, this statement will be executed once the asynchronous function completes. So you write your await, okay, you execute your method, you reach the await executes, the asynchronous function executes somewhere else on another thread somewhere. The method that contains the await returns, and then you carry on doing whatever you were doing before. Then later, the asynchronous function completes. And then what happens is that the thread of execution is going to resume on the statement that comes immediately after the await. And inside that statement, you could do something useful, like such as updating the UI, and you could do it because you're executing inside a caller's thread. So you're not inside a worker thread, you're not inside a different thread, you're inside the caller's thread. So whatever thread was calling your method in the first place, now this same thread is executing the code that's after the await, and that executes after the asynchronous operation completed. So this is very nice, allows you to write a flow of execution that seems very logical when you read it. It saves you from having to write callbacks, and the code seems much more natural. And then it makes things really easy to use, especially when you have a sequence of such calls. If you are writing it with another method than await, it could become very tedious very quickly. With await, it actually looks really nice. In C++ 11, you can use the thread class. So the thread class, it was not there before C++ 11. When you wanted to create a new thread, well, you couldn't actually use, there was nothing inside the STL to allow you to do that. You had to use operating system specific primitives, such as in Windows, Win32, there was I think it was a create thread X Win32 API that would allow you to do that. In Unix, it's something else. I actually remember at the time when I was doing a training period in a German university, I had to write a signaling layer that was using multiple threads, and that signaling layer was supposed to work under Windows and Unix. And so that part of the code that was creating threads was different between Windows and Unix. And I wrote one version for Windows, one version for Solaris, but when my tutor took my code and had to urgently migrate it to another flavor of Unix, he actually cursed me because my code was not portable, because it was actually creating threads, and at the time you couldn't write portable code when it created threads. Well, now that's over, and in C++ 11 there is a thread class that simply allows you to create a thread, whatever operating system you're compiling your code against. C++ 11, there's a keyword called async. You can call it with a lambda to call a function async.
Hey!
to meet you.
Hey,
I'm Matt.
buddy, hey.
Where are you from?
South Iceland.
South Iceland.
Yeah,
So
about an hour to get here.
you're English.
Yeah.
Have you drunk already? Have you you've drunk a few beers
Yeah,
already?
a few beers. You smell it?
Yeah, sort of. That's good.
Where's this food?
This is for my blog. It's a technical blog.
Alright.
I talk about.
It's a recording.
It is. It is live. It is live.
Yeah?
It's streaming live on YouTube right now.
Oi, oi! You're a liar.
Cheers. Bye bye. Matt.
Go on, Matt.
Bye bye. Have a good day. So the async keyword in C++, you can also use the async keyword, which, by the way, has nothing to do with the async keyword in C#. The async keyword in C++ allows you to do the same thing as task.run in C#. That means you write async, then a lambda for the asynchronous call. The asynchronous call is going to execute somewhere else, and that thing will return immediately, and it will return a future. And that future, it's an object that you can later use to check the status of your call. So you can block until the call completes, or you can check the completion of the call. That's very handy, and it behaves exactly the same way as a task of T object in C#. There is actually no equivalent in C++ of the await keyword. That doesn't exist. So async is simply the same thing as it's getting a future. So it's the same thing as doing a task.run in C#. It's convenient. This is completely different from the async keyword in C#. Okay, the async keyword is hello. The async keyword in C# is actually now it's the other way. So in conclusion, in C#, if you're making asynchronous calls, use either task.run or await, and in C++, use async. And well, that's it. That's quite simple. But actually, it's not. Of course, do not forget to synchronize, and that's where the difficulty lies. Of course. Ni hao.
Ni hao. I'm so excited that I came to the Shard today and can see the whole view of London City. Very wonderful.